That's your heart rate for your EKG. You're down around somewhere around 100 hertz. Right there, 100 hertz. Okay. And then what's important to us, I try to massage all this so you don't need to learn all the ifs and buts. You learn the important stuff that it makes sense to you. Okay, as I said, we're talking about now down here sound. Sound. Write down sound under there. Okay, now draw another line up at the top, down. Okay, that's 20,000 hertz. And draw that down to sound, that line. That's as high as your ear can hear. That's as high, my ear can't hear that. Most older people can. Most young people can hear some of it. Okay? Those are high frequencies, flutes, piccolos, and so on. Okay? So that is sound. Now we're going to go from there up to radio waves. So draw one maybe twice that far away. And write radio waves. That ends the radio wave. So down there now is the radio waves. Okay? Those are the waves that you're going to use to talk on the radio. That includes AM, right? AM, FM, okay, TV, CW, that's Morse code. That's good. So if you're going to get a ham radio license, you got to go there. Yesterday they had, now think about this, they had a 40-foot antenna. So we know as a general rule, as we've talked about before, antennas are 1/2 wavelength, 1/4 wavelength, and 5/8 wavelengths. So if that antenna is 40 foot times 3, that's 120 meters. Okay? So if it's a dipole half, that antenna theoretically could be tuned and could get something at 240 meters. It's a dipole. So yesterday they were working at 200 meters with that big antenna, from what I'm told. Okay. We were not. So that was Jota. Write down Jota. Down at the bottom, there. Okay. So on the other side, a J-O-T-I. That's where we were. So draw just somewhere there, not too far away, 2 lines cross. Cross. Like you drew the other one, down. Okay, 2. You got 2 of them? Now together. Now these are the most common ones that you know and you use all the time. One is 2.4 gigahertz, hertz, gigahertz. The other one is 5.8.
I don't know if it's capital G or
Now, under the GP 2.4, draw another line down, and right there. Now, try to get this in your head, but it's not too important, but it starts to something. That has been designated by FCC as far as science, industry, and medical. So write that, just write SIM. Industry means your cell phone. So right now, we are out of space around the world on 2.4. Therefore, if you're going to fly a drone, more than likely, you're going to fly the drone with 5.8 and see the video. Draw a line down. Okay. This is where the drones get complicated because you have 6 antennas now. You don't have 1 anymore. You have 6. And that's what we're going to talk about next week. And now we go up from there and draw 3 lines down RGB. Okay, and before RGB, draw a line going up. Okay, the line going up for R, okay, is infrared. The one above blue going up is ultraviolet. So I saw Lisa dance at her church in ultraviolet light. So we tend to use ultraviolet light to see a white sheet, and it comes out different colors, very purple frequently. Infrared we tend to use for various things too are clickers that control all TVs. If you look at that on your cell phone, I showed you how to do that before. When you click, you'll see the infrared, but your eyes won't see it. So once you start designing this, or learning it, or teaching it, all this becomes important. So far we're relatively safe. Okay? Now I don't think today we want to talk about, but as we go up, we get to X-ray. So no, don't write it down. Above X-ray we get gamma rays. Above gamma rays we get cosmic rays. Those are dangerous. Those will kill you. Ultraviolet from the sun will kill you. So you've got to know how to handle ultraviolet. Okay? So now what we've got to talk about is draw the sun up there in the left corner. No, down underneath. Just draw a line, start a new system. Sun. Okay, now draw the earth down at the bottom as a sphere. Just a little one. No, a big one. Over the whole board. I'm sorry. I realize I'm sorry. Erase them. Erase them. I can't erase. Okay.
Yeah.
Okay, we'll do it here. And just draw like so. Up, over. That's the Earth. Okay. We can use these other planets. Okay. Sun, Jupiter. We're going to be working with Jupiter between now and eclipse. Moon. These are the 3 big ones. So right down there, Sun. Jupiter. Moon. Okay. Now draw another line here and maybe one there. And this would be a lot easier to understand when you see it in the slides. What we're talking now is about our atmosphere. Are we the only planet in the universe out of billions of planets where people live? You have to decide that yourself. Every scientist has to decide that. We started an organization a few years ago called SETI, S-E-T-I, Search for Extraterrestrial, whatever, individuals. Still going. Poorly funded. It was funded well by the U.S. government. But when the scientists finally said it's quite unlikely that we will find anybody, and if we do find them, it will be 25,000 years before we know it, we're going to put any money into it. So they pulled the money, so CETA is still going. But for the ham radio people, and hematology, and armies around the world, and the pretty girls in Brazil at carnival time who like to get a suntan, okay, that ionosphere, the atmosphere, is very important. So draw down on the left side there. Start down at the bottom, a D, just put D, E above it, F1, and F2. Okay? So the first thing you have to know from where you stand in life, if you get on an airplane, you're going to fly about 30,000 feet above the Earth. Okay. We found out that the Chinese can fly a balloon at 60,000 feet across the ocean and over the whole United States, and we only have one airplane, multi-million-dollar airplane, that can take it out. So obviously the thing for the enemy to do is find one that will go 70,000 feet, right? So anyway, now we're talking about getting into the ionosphere. The ionosphere is divided into segments. You have some other parts too. I don't want to go through over it too much. It's just, you have a stratosphere. Airplanes can fly in the stratosphere. However, these radio waves that are very, very long, okay, so the radio waves that are very, very long will bounce off of the D, the E, and the F. Okay? So put that under the top one. Way over there. Bounce. Just put bounce. Okay. Okay. Depending on how dangerous they are, the cosmic ones and so on, the high frequency one will actually go right through the ionosphere into space, and they'll go forever till they run out of energy. Okay? The same way coming from the sun. So the sun sends down this heat. So when the sun put H2, hydrogen, then an arrow, we've gone over this before, arrow to He, helium. Now most of our body is water, H2O. Therefore lots of hydrogen. That's what makes an MRI, magnetic resonance. Hydrogen is the most common atom in the universe. Okay? So what the sun is hydrogen, a big ball, plasma of hydrogen turning into, through a different mechanism called fusion, into helium. Now to think about fusion, it's a little confusing, but it's extremely powerful. It's what the atomic bomb is made out of, fusion. So one of the good physicists, female physicists, the way she explains it, he says, I like to play pool. So she shows herself at a pool table, and then she makes it very, very long, like an accelerator or a cyclotron. So think about a very long pool table. Now you hit the cue ball, and you gonna hit the 8 ball. Now you hit it so hard and so fast that the physics and the math tells it to fuse. So now those 2 balls turn into 1. With that comes lots of energy out. And that's the energy that we're going to see in radio astronomy with an antenna in the spectrum.
Oh, it's like a sun. It's not a sun.
So they call that the hydrogen, okay, write down hydrogen, okay, band. Now JV, from your standpoint, probably the week after next with the parabolic antenna, that's what we'll be looking for. The hydrogen band, and we'll show you mathematically how they decide what the frequency is. That frequency is about 1240.5. Write that down. Hertz.
What'd you say?
1240.5. So we know how to do soft-defined radio. So you connect your soft-defined radio to a parabolic antenna with a powerful LNA, and we can find the sun. And hopefully by April we'll be able to find Jupiter. Any questions on any of that? JV? No?
No.
Okay, this is tough stuff. Turn it over. No, I forgot to expound on one thing there. Just remember, when I said that will bounce, the first thing a radio wave will do is go around the Earth. Okay, that's what you call grounding, around the Earth. Roy, you can stop the camera a minute.